Good morning, students. This is Adyagatla Nagaraju, lecturer in Electrical and Electronics Engineering, Government Polytechnic, Station Ganpur. So today we are going to learn DEEE fifth semester's AC Motors subject. So in AC Motors, single phase induction motors topic we are covering. So in single phase induction motors, capacitor start motor and capacitor motor. These two motors we will discuss today. So in last class we have seen that based on the starting method, five different types of motors: shaded pole, capacitor start, capacitor start and capacitor run, split phase motor. So in that split phase motor we have discussed. And capacitor start motor and capacitor motor we will discuss today. So we have discussed about types of single phase motors. So how many types? Five types of single phase motors we have discussed. Split phase, shaded pole, capacitor start, capacitor motor, capacitor start, and capacitor run. These five types of motors we had discussed in yesterday's class. So coming to the objective of today's lesson. So on completion of this topic, you will be able to know that capacitor start motor, main components of capacitor start motor, working principle of capacitor start motor, applications of capacitor start motor. So what is capacitor start motor and the main components of capacitor motor, working principle of capacitor start motor, and applications of capacitor start motor. These topics we will discuss on today's class. And torque speed characteristics also. So similarly, we will know capacitor motor, permanent capacitor motor, and its main components. Same, its working principle, its torque speed characteristics, and applications. So we will cover main components, working principle, torque speed characteristics, and applications for capacitor motor and capacitor start motor are two motors we will discuss on this lesson. So Capacitor start motor. This is the capacitor start motor. We can find the capacitor here. Single phase capacitor start motor. So we will find the capacitor here. This is the capacitor start motor. This is the split phase motor. Here the winding is split into two parts. One part, this is the one part, and this is another part. So this is the main winding. This is the auxiliary winding. We have a centrifugal switch in series with the auxiliary winding to open the auxiliary winding in running conditions. In running conditions. Capacitor start single phase induction motor. It is also known as capacitor start induction run motor. Capacitor start induction run motor. It is an improved form of resistance split phase motor. Improved form of resistance split phase motor. Fundamentally, it is very similar to a resistance start split phase motor, but starting winding of a capacitor start motor has a few number of thick wires. Electrolytic capacitor is used in place of resistance. Here, instead of high resistive nature, we are using only few number of tons of thick wire. Means large cross sectional area means less resistance. Instead of high resistance, we are offering low resistance, but in series with a capacitor. Electrolytic capacitor is used in place of resistance. So it is an improved form of resistance split phase motor. Fundamentally, it is very similar to resistance start split phase motor, but starting winding of a capacitor start motor has few number of tons of thick wire. Electrolytic capacitor is used in place of resistance. This is the capacitor start induction motor. Here it is the main winding. This is the starting winding in series with a capacitor and a centrifugal switch. Generally, the rotor is the spherical cage rotor. The main winding has a high inductive image, but capacitor start motor starting winding has a capacitor in series with the starting winding. That is the auxiliary winding and a centrifugal switch in series with the auxiliary winding. In series with the auxiliary winding. Coming to the construction of capacitor start induction motor. Capacitor start induction motor. The capacitor is connected in series. Capacitor is connected in series with the starting winding. By choosing proper capacitor value, starting winding I start at standstill can be made to lead main winding current IM by 90 degrees. So capacitor is connected in series with the starting winding. By choosing proper capacitor value, starting winding current at standstill can be made to lead the main winding current by 90 degrees. 90 degrees means both are equally inductive, but auxiliary winding has a capacitor. So the auxiliary winding current leads the main winding by 90 degrees. Right? 90 degrees. Capacitor usually mounted in a metal casing on the top of the motor. See, we have seen here capacitor is mounted on the top of the casing. Okay, capacitor usually mounted on a metal casing on the top of the motor. In some cases, capacitor is mounted inside the motor housing. In some cases capacitor is mounted inside the motor housing. The capacitor used is of electrolytic type designed for short duty service. Capacitor is used for short duty service and it is a electrolytic type capacitor. Electrolytic type capacitor. The size of the capacitor motor. Size of the capacitor motor. Capacitor depends on the rating of the machine. So the capacitor of a capacitor start motor rating depends on the size of the rating of the machine. Depending upon the rating, the size of the capacitor we will use. It is around 50 microfarads to few hundred microfarads. The value of the capacitance around 50 microfarads to few hundred microfarads. It founds application where high starting torque is essential. It founds application where high starting torque is essential. High starting torque is essential. Centrifugal switch is disconnected when the motor picks up speed. The centrifugal switch is disconnected when the motor picks up speed. Now the auxiliary winding is separated. Because of short duty service of electrolytic capacitor, proper operation of centrifugal switch is important. Because of the short duty service of electrolytic capacitor, proper operation of centrifugal switch is important. The main and starting windings are space displaced by 90 degrees. By 90 degrees means both have equal inductive reactance and a main winding has 90 degrees lagging due to lack of capacitor in main winding. Okay. The time displacement is achieved by a capacitor in series with the starting winding. The time displacement of 90 degrees is achieved by a capacitor in series with the starting winding. So capacitor start induction motor. The main winding current lags. The main winding lags the voltage by 5 m and I starting current leads the voltage. Starting current leads the voltage by 5 start because it has a capacitance. The angle between the IM and IST, main winding and starting winding being alpha, which is nearly 90 degrees. The angle between main current and starting current being alpha, which is nearly 90 degrees. A phase displacement is achieved. The motor develops high starting torque. Motor develops high starting torque. Coming to the working principle of capacitor start motor. Working principle of capacitor start motor. When the single phase supply is given to the motor picks up speed up to 80% of rated speed. When a single phase supply is given to the motor picks up speed up to 80% of rated speed. The capacitor is in the circuit only during starting period. When the motor picks up speed, the capacitor and starting windings are automatically disconnected with the help of centrifugal switch. So when the single phase AC supply is given to the motor picks up speed up to 80% of rated speed. The capacitor is in the circuit only during starting period. When the motor picks up speed, the capacitor and starting windings are automatically disconnected with the help of centrifugal switch. With the help of centrifugal switch. The capacitor can be selected as per the requirement of starting torque. It can be high as 350 to 400 percentage of full load torque. So the capacitor can be selected as per the requirement of starting torque. It can as high as 350 to 400 percentage of full load torque. 350 to 400 percentage of full load torque. It is the high starting torque motor. The torque speed Characteristics are as shown. Torque, speed. Characteristics are as shown here. Here, starting 350 to 400% of full load winding due to main and auxiliary winding. When the motor picks up 80% of its rated speed, then the auxiliary winding is cut off and the characteristics follow the main winding only. Main winding only. Okay, this is the characteristics of capacitor start motor. Capacitor start motor. Phasor diagram of capacitor start induction motor. The capacitor's current draws leading current. Capacitor current, that is the starting current, draws leading current, and the main field winding current lagging current, and the resultant current is the I. Capacitor start motor speed reversal. It can be done by either reversing main winding terminals or starting winding terminals. Capacitor start motor speed reversal can be done by reversing the main winding terminals or starting winding terminals. You can change any one but not both. But not both. Coming to the applications of capacitor start motor. Coming to the applications of capacitor start motor. It is used where high starting torque is needed. It is used where high starting torque is needed. That is compressors, pump sets, air conditioners, conveyors, etc. High starting torque needed where compressors, pumps, air conditioner, conveyors, etc. etc. This is the capacitor start motor. This is the capacitor start motor. This is the capacitor motor. Capacitor motor. So it can be also called as permanent capacitor motor. Capacitor motor or permanent capacitor motor. Features of capacitor motors. It has no centrifugal switch. Capacitor remain in the circuit permanently. It is of oil type capacitor. This improves power factor. This is the capacitive start mode, capacitive permanent capacitor motor. It has the main winding, it has the starting winding, it has the capacitor in with the starting winding, but we don't have a centrifugal switch to disconnect the auxiliary winding from the supply. So it has high power factor. In previous case, capacitor start motor has high starting torque, but it has high power factor. This is the animated picture of capacitor starter motor. Here, this is the main winding and this is the auxiliary winding in series with a capacitor in series with a capacitor. The performance are at starting and running conditions depends on the value of capacitance C. C is designed to have best starting and running conditions. Generally, it is a oil type. Starting torque is about 50 to 100%. 50 to 100%. Phasor diagram of capacitor motor. The current in the starting winding leads the voltage and the current in the main windings lags the voltage and the resultant current should be lags the voltage but small angle, so it has high power factor. High power factor. Torque speed characteristics of capacitive motor shown here. The starting torque is around 50 to 100% of full load torque. Advantage of leaving capacitor permanently. High power factor, higher efficiency, increased overload capacity, noiseless running of motor. These are the advantage of permanent capacitor. Has a high power factor, higher efficiency, increased overload capacity, noiseless running of the motor. Speed reversal. It can be done by reversing either the main winding or auxiliary winding. It can be done by reversing either main winding or auxiliary winding, but not both. But not both. Coming to the applications, suitable for applications requiring low starting torque like fans, blowers, oil burners, etc. These suitable were the applications requires low starting torque like fans, blowers, oil burners, etc. So coming to the summary, we have discussed the capacitor start motor is one of the split phase motor. The phase split is obtained by a capacitor in series with starting winding. The capacitor and starting winding are cut out of the circuit when the motor picks up speed. When the motor picks up speed. Suitable for high torque applications, and the capacitor motor is one of the split phase motor. The phase shift is obtained by a capacitor in series with starting winding. So it has no centrifugal switch. The capacitor is in the circuit permanently. Power factor is improved. Power factor is improved. Starting torque has less starting torque, only 50% to 100%. Coming to the quiz. In a ceiling fan employing permanent capacitor motor, in a ceiling fan employing permanent capacitor motor. Option A. Secondary winding surrounds the primary winding. Primary winding surrounds the secondary winding. Both are usual arrangements, none of the above. The ceiling fan employing permanent capacitor motor. Secondary winding surrounds the primary winding. Primary winding surrounds the secondary winding. Both are usual arrangements, none of the above. So secondary winding surrounds the primary winding. Secondary winding surrounds the primary winding. In comparison to resistance start, induction motor, the permanent capacitor motor option A is more expensive. Option B has better power factor. Option C has better starting torque. Option D all of the above. So, in comparison to resistor start induction motor, permanent capacitor motor, permanent capacitor motor has more expensive, has better power factor, has better starting torque. So, all of the above. In comparison to capacitor start, capacitor run motor. In comparison to capacitor start, capacitor run motor, option A, simple construction and low cost, option B, poor power factor, option C, poor starting torque, option D, all of the above. So, comparison to capacitor start induction motor, capacitor run motor, simple construction and low cost. It has poor power factor, poor starting torque. So, all of the above. In a capacitor start induction motor, capacitor is connected through a switch. Option A in series with the auxiliary winding. Option B across the auxiliary winding. Option C across the main winding. Option D in series with the main winding. So in a capacitor start induction motor, capacitor is connected through a switch. Option A in series with auxiliary winding. Option B across auxiliary winding. Option C across the main winding. Option D in series with the main winding. So in series with the auxiliary winding. In series with the auxiliary winding is the correct answer. A capacitor selected for capacitor start motor should be rated for option A peak voltage, option B RMS voltage, option C average voltage, option D none of these. A capacitor selected for capacitor start motor should be rated for option A peak voltage, option B RMS voltage, option C average voltage, option D none of these. Answer peak voltage. Peak voltage. The capacitor employed in a capacitive start motor. Capacitive motor now. Option A voltage rating. Option B polarity marking. Option C dielectric rating. Option D define capacitive volt value. Capacitor employed in a capacitive start motor. No. Option A voltage rating, option B polarity marking, option C dielectric rating, option D define capacitor value. Answer polarity marking. Polarity marking. The value of capacitor of capacitor start motor is determined by option A speed, option B efficiency, option D starting torque, option D power factor. Value of capacitor of the capacitor start motor is determined by starting torque because capacitor start motor has high starting torque. High starting torque. In a capacitor start induction motor, capacitor is connected to a switch in series with the auxiliary winding option B across auxiliary winding option C across the main winding option D in series with the main winding. In a capacitor start induction motor, capacitor is connected to a switch in series with the auxiliary winding. In series with the auxiliary winding. Capacitor in a single-phase induction motor is used for improve power factor, improve the starting the motor, reducing the harmonics. Capacitor in a single-phase induction motor is used for improve the power factor, improve the torque, starting the motor, and reducing the harmonics. Starting the motor. In a capacitor start one-phase induction motor, the current in the auxiliary winding. Current in the auxiliary winding. Option A lags the current IM in the main winding. Option B in phase with the main winding. Option C leads the main winding by 90 degrees. Option D leads the IM by 80 degrees. In a capacitor start one-phase induction motor, the current in the auxiliary winding leads the main winding by 90 degrees, but practically it is about 80 degrees. Ideally, it is 90 degrees, practically it's about 80 degrees. Single-phase induction motor can be reversed by interchanging the terminals of option A, capacitor, option B, supply, option C, centrifugal switch, option D, starting winding. Answer, starting winding. If the capacitor of a capacitor start motor fails to open when it picks up the speed, the motor will stop. Option B, auxiliary winding will get damaged. Option C, the capacitor will get damaged. Option D, the main winding will get damaged. If the capacitor of a capacitor start motor fails to open when it picks up the speed, the capacitor will get damaged. Capacitor will get damaged. Compared to resistant split-phase motor, a capacitor start motor has option A high starting torque, option B low starting torque, option C high running torque, option D low running torque. Answer, high starting torque. High starting torque. Capacitor start induction motor is switched on to a supply with its capacitor replaced by an inductor of equivalent reactance. The motor will, option A, not start at all, option B, start and run slowly, option C, start and run at a rated speed, option D, start with humming noise. So not start at all, not start at all. If the capacitor of a capacitor start induction motor is short-circuited, the motor will, option A, start, option B, not to start, option C, burn, option D, start with jerks. If the capacitor of a capacitor start induction motor is short-circuited, the motor will not start. If the capacitor of a capacitor start induction motor fails to open when it picks up the speed, the motor will stop, the auxiliary winding will get damaged, the capacitor will get damaged, the main winding will get damaged. Answer, the capacitor will get damaged. Capacitor will get damaged. Coming to the assignment, go through the properties of electrolytic capacitor, AC through pure resistance circuit, AC through pure capacitance circuit. Coming to the frequently asked questions. Explain capacitor start motor. Draw the torque speed characteristics of capacitor start motor. Explain the capacitor start motor. Draw the torque speed characteristics of capacitor start motor. Okay, they are the frequently asked questions. Thank you. If you have any doubts, you can contact me through my mobile 9866930004. Okay. Thank you.